Let's write an inverse variation equation. So we see that the variables x, y vary inversely. So really important that you read that. It varies inversely. And y equals 4 when x equals 3. So we're supposed to write an equation that relates x and y. Then we have to find when x equals -2. So let's write the general equation for inverse variation, which is y equals a over x. So what we're going to do is we're going to substitute for x and y. So we know that y is 3, y is 4, and x is 3. So we write 4 equals a over 3. Then we solve for a. So to solve for a, we multiply by 3 to each side, and therefore a equals 12. Then we're going to write the inverse variation equation with the a equals 12. So you must write y equals 12 over x. Okay, so that's the first thing. So that is what we're looking for, the equation that relates x and y. The second thing is that you solve for y given when x equals -2. So we'll plug in -2 for our equation. So we have y equals 12 over -2. Therefore, y equals -6. And we're done. So those are the two things that you need to make sure and write when you are trying to find the equations. So please try out these 3 examples down here. And when you come back, I will have the answer for you. Another thing to be careful of is that you're going to find y when x equals 2 this time, okay? When x equals 2. Try these out. So if you try these out, you should have gotten y equals 20 over x for number 6, and then y equals 10 when you plugged it in. And then for the next one, you got y equals -6 over x, and then you plugged in 2 for that equation, you get y equals -3. Then for the last one, number 8, so you notice you have 16 equals a over a half. So another way to think about that is that 16 equals a divided by a half. So when you're dividing by a fraction, you multiply and you flip it, right? Or you flip it and then multiply. So therefore, it's 16 equals 2a. Then you solve for a. Therefore, a equals 8. So then you plug it into the equation. Y equals 8 over x. And then when you plug in 2, y equals 4. All right, let's take a look at example 4, so modeling with mathematics. So in this example, the time t in hours that it takes a group of volunteers to build a playground varies. Inversely, it varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. Make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. What happens to the time it takes to build the playground as the number of volunteers increases? So let's write the general equation for inverse variation first. So that is y equals a over x. So we're trying to figure out, though, is time. So let's change it. It should be time equals a over the number of volunteers. So what we're going to do is we're going to substitute. So it takes 10 volunteers 8 hours. So we're going to write 8, we're going to substitute 8 equals 8 over 10, right? That's the number of volunteers. N is the number of volunteers. It says it right there. So therefore, we solve for a. So a equals 80. So then our general equation, therefore, is t equals 80 over n. Okay, so that's the general equation we are using. So that's the inverse variation equation that we were asked to find right here. So now we're going to fill out the table of values using the numbers in here. So n is 15, so we're going to just plug it in. So 80 over 15. And then you need to make sure and convert it into hours and minutes. So one way to do this is just figure out how much does 15 go into 80, right? So let's see. So we know, so let's convert this to time, right? So 80 so time equals 80 over 15. And so we know 15 goes into 80 about 5 times. So 5 times 15 is 75, so therefore, let's see, 80 minus 75, that would be 5 over 15, right? So 5 hours and 5/15. So we need to convert that. 5/15, we need to figure out what is the minutes for that. So 5/15, let's just write a ratio. 5/15, not 16ths, 5/15 equals what over 60? Okay, so there's 60 minutes in an hour. So you can solve this either by cross multiplying. Okay, you can cross multiply to solve for x. So let's see, 300 equals 15x divided by 15. So 300 divided by 15 is 20. Okay, so 20. So that means this is 5 hours and 20 minutes. So really the hardest part about this, I think, is converting it from hours, from the fraction to the hours and minutes. Okay, so go ahead and try out the rest of these. So again, you're plugging in 20 for n into this equation here, and then see if you can figure out how to convert these all to hours and minutes. Okay, pause the video and try it out. All right, so if you tried this out, you would get, for number 20, 80 over 20, that's exactly 4 hours. Then you would get 80 over 25, which changes to 3 hours and 12 minutes. And then 80 over 30, that would be 2 hours and 40 minutes, okay? So I would spend some time trying to figure out how to convert these to minutes. One idea, of course, is whatever's left over, go ahead and doing some kind of a proportion. So it would be whatever's left over, like we did on the first one, we had 5 left over, so 5 over 15 equals x over 60 to find out how many minutes are there. So the last one is, what if an example 4 takes a group of 10 volunteers 12 hours to build the playground? How long would it take a group of 15 volunteers? So pause the video, try this one out. We just want to find that one time, and I'll give you the answer when you come right back. All right, so hopefully you tried this out. So again, you write the general equation, T equals A over N. We know that N, the number of volunteers, is 10, and time is 12. And then, so we figured out what A was, then we wrote our general equation. Then how long would it take a group of 15 volunteers to build the playground? So we plugged it in. And at the end, the final answer is time equals 8 hours. So I hope this helped you out. And on Monday, you will take an e-ticket. Thanks for watching.